Welcome back. Alright, so now we're at Apache Spark. And if you recall from previous videos, MapReduce fatal flaw was that it read and wrote to a physical spinning hard disk constantly. And Spark fixes this by doing its heavy lifting in RAM, your computer's short-term lightning fast memory. And the core data structure that makes this possible is called the RDD. And RDD stands for Resilient Distributed Dataset. Now let's break that down. Now, data set, obvious, right? It's your data. Distributed means it's chopped up and spread across your entire cluster of computers, just like HDFS, but resilient. So, resilient is like the key word here. So, RDDs are completely immutable. Tying back to our Scala video, they are like a valve, right? You cannot change an RDD once it's created. If a node crashes and loses its chunk of data from RAM, Spark doesn't panic, because the data is immutable, and Spark remembers the exact math operations used to create it. It simply rebuilds that lost chunk on another node from scratch. Keeping things in RAM is why Spark absolutely destroys Hadoop's MapReduce in speed tests, running always, 100 times faster usually. So because Spark is processing massive amounts of data in memory, it has to be incredibly smart about when it actually does the math. It does this through a concept called lazy evaluation. So in Spark, there are two types of operations: transformations and actions. So transformations are like things like dot map or dot filter. When you write a transformation, Spark does absolutely nothing. It doesn't process a single byte of data. Instead, it just takes notes. It builds a map of your logic called a DAG, or a directed acrylic graph. It is literally just writing a recipe. And Spark waits until you trigger an action, like asking, to dot count or dot collect. The moment you hit an action, it starts hitting start on the oven, basically. Spark looks at the entire recipe you wrote, figures out the absolute fastest, most optimized way to bake it, and then executes everything all at once. By being lazy, it avoids wasting time calculating intermediate steps you might not even need. Now, writing Spark code feels just like writing normal Scala code, which leads beginners into a massive pitfall known as the closure trap. So imagine you want to count how many blank lines are in a dataset. You create a simple variable on your main machine called counter. Set it to 0 and tell your Spark RDD to loop through the data and add 1 to the counter every time it sees a blank line. You run the code, it finishes, and you print your counter and it says 0. Why? Because your code was packaged up or closed into a closure and sent over the network to the worker nodes. Those workers were updating their own isolated local copies of that variable in their own RAM. Your main machine, the driver, never saw those updates. To fix this, Spark uses a special shared variables called accumulators. An accumulator is specifically designed to let worker nodes safely add values together and report them back to the main driver without causing race conditions or data loss. In distributed computing, you always have to remember where your code is actually running. And thank you for watching.